Hello everyone, my name is Borna and I would like to share with you the results of our recent research which explores the effectiveness of trees and vegetation in dispersing air pollutants at pedestrian level. Sadly, for the past few decades, human activities and lifestyles have consumed ever more of the Earth's resources and released ever-growing waste and pollution into the environment, in particular polluted the air that we breathe and impacted our health. The health impacts of air pollution are being addressed by a substantial body of research worldwide, whilst relatively little research has investigated the role that the built environment can potentially have on the concentration and dispersion of air pollutant. Whilst the best way to tackle air pollution is to reduce and stop the pollutants at their sources, which must always be the primary focus of air quality policies, as a secondary method and one which has been increasingly perceived as effectively removing pollutants and improving urban life is urban greenery. In order to validate this understanding, we conducted months of detailed fieldworks and spot measurement of both pollutants and microclimate parameters, and complemented this by computational simulation studies for validation and prediction. In this paper and presentation, we only share data with a greater significance, but the conclusion is based on the result from our full research duration of 52 days. As an empirical basis for this investigation, this paper intentionally conducted its research far from the roadside and within an open courtyard, which was identified as a high-quality, busy urban space which encouraged the user to stay for longer periods of time, therefore increasing the risk of being exposed to pollutants. The study site located within the Regent's Place pedestrian plaza, which is located adjacent to Euston Road, which is one of the most polluted roads in London. The Regent's Place characterized by a street canyon configuration with an aspect ratio of 1.81 and a sky view factor of 0.35, and the built-up areas are 15 times greater than the green spaces, including trees, hedges, and green roofs. The plaza gets busier during lunchtime, and for that reason, this study conducted between 11 a.m. and 3 p.m. and over the summer period, where the square was expected to be much busier than other times. In that respect, the site divided into two characteristics: locations with the highest activities and a greater number of people density, for example, location B, C, and D, and locations which were seen to offer a better understanding of how air pollutants enter the site and disperse from the site, for example, A, E, F, and G. Information related to vegetation characteristics were also gathered and identified during the study and used in further computational modeling. Air pollutants and micrometeorological parameters measured for the period of 30 minutes at each point, with readings taken every 5 minutes, and average values have been locked in for further use in computational analysis at modeling stage. All gathered data have been compared and ratified against the live official data and the nearest fixed meteorological and air quality monitoring station to the site. Of the 52 days of monitoring, we are presenting the 3 days, which are a good representation of London's various weather conditions. The first item revealed from the fieldwork was that 3rd August, which was a sunny day, recorded as the most polluted day in comparison to 9th and 24th, which were rainy and windy days. This is more distinct when we look at PM10 and 2.5 levels, and less noticeable in the case of NO2 levels. Interestingly, the results of rainy day recorded PM10 and 2.5 at even lower level than a windy day, but still NO2 was relatively high, and this has been identified as a recurring pattern for all other study days. Interestingly, the high level of pollutants concentration can be found around the sets of trees which are located on the east and west side of the plaza, in this case location C and D, and not location A, which is closer to Euston Road. Parallel to the spot measurements, the complex microclimate phenomena and a range of urban features have been modeled and simulated in ENVIMET. In order to correlate the relationship between vegetation and pollutants concentration, in addition to modeling the current scenario, a no-green scenario has also modeled and simulated for the plaza. The results from ENVIMET showed that the relative humidity is much lower and temperature is higher in the no-green scenario. The wind aspect is the most interesting finding. Based on the result of the fieldwork and ENVIMET simulation, it is clear that trees in high and low-density urban areas affect the wind velocity and its behavior. As you can see on the image on the left, wind velocity and vegetation have inverse correlation. For air pollution, PM2.5 is 120% greater around a group of trees in location C, and PM10 values are even higher and stand at 175%. Meanwhile, NO2 values are only slightly higher in comparison to no-green scenario. It is worth mentioning that the impact of trees on wind flow greatly depend on the vegetation shape and species, as well as the density of the urban context. For example, planting high LAD, heart-shaped or spherical crown-shaped trees with low clear stem height and little space from each other could slow down air velocity at pedestrian level and increase the concentration of pollutant. Further analysis of the results showed that the large hedgerow located at the south side of the site, in this case location A, is the most effective element in dispersing or blocking pollutants. For that reason, it has been decided to take this strategy a step further and pilot scenarios where hedgerows can be employed as a barrier and stop the PMs from congregation under the group of trees at location C. The first scenario A was to add a parallel hedgerow immediately after the near wake of the existing hedgerow. The result shows a pronounced reduction in pollution level, PM10, and has limited the distance which air pollution can travel. Furthermore, it has been noticed that the inlet airflow partly blocked by the 2 rows of hedges and separated upward and generated a skimming flow. In the second attempt, and in order to avoid the formation of skimming flow, the 2-meter hedgerow increased to 4-meter height. However, the simulation outcome showed that the 4-meter height porous barrier is not enough to influence the flow turbulence. For that reason, in the third attempt, a 4-meter hedgerow has been replaced with an 8-meter Tilia tree, which is similar species as to the group of trees at east side of the site, to offer protection over a larger distance downwind. Results showed a further reduction in the distance which air pollution can travel, but not much difference in terms of air pollution concentration at pedestrian level. For that reason, and as final mitigation strategy, both hedgerow and tall trees put back in the suggested places to provide a maximum protection in terms of distance, downwind and pollution concentration at pedestrian level. The final mitigation scenario showed more than 53% improvement in air quality and concentration of pollution under the group of trees located in east and west side of the plaza. In conclusion, whilst many studies agree in general on the mitigation of urban air pollutants by vegetation through their deposition and dispersion properties, the results of current research contradicts this common understanding and demonstrates drastic increase in the concentration of particulate matters in the vicinity of trees. The results highlight that trees reduce wind velocity and air movement, causing pollutants to settle around and under trees' canopy. Therefore, planting more trees does not necessarily mean less pollution, at least locally. Instead, to reduce pollutants concentration, more attention should be given to vegetation configuration, type, scale, and most importantly, their location and distribution within urban spaces. Needless to say that we need more effective tree planting policy which takes these challenges into account, and urban planners need to consider the impact of urban trees and greener spaces on air quality at hyperlocal scale. Dr. Rosa and I would like to thank PLIA for providing this platform for us to share our paper. Thank you for listening.